So different operators that we need when we are writing programs are also supported in Python. The comparison operators, you have to use double is equal to say if x is equal to 8. If you are assigning single is equal to, otherwise less than or equal to, greater than or equal to, all the operators that we need when we are writing program is all here also supported. There are different Python syntaxes. We have to remember those Python reserved words because they are case sensitive. If I'm writing print in capital letter, capital P-R-I-N-T, it will not recognize. So whatever we want to write, we have to write it in a small letter. Otherwise, if condition is there, loops are there, we can import the different programs available with Python. For outputting, as we said, we are using print. For accepting input, the earliest version, if you are using them, they are with this syntax, row input, row underscore input, then within bracket, we have to write the string that can help us to remember what to input. Then we can assign the input into one given variable. Nowadays, rather than row input, we are using just input, which will simplify to remember. Like take this example. I want to ask individuals to give me their name and when they were born. Then using that, I can display their name and their age. So it asks, what is your name? Print what's your name? Within quotation mark, we have to write what is your name. Then name is equal to, name is a variable which takes whatever we input through input. This one is just to have a cursor where to write. Print what year were you born? Input some number. Then print string, the name of the person is D integer years old. So it accepts name, and then from the current year, it will subtract the birth year. Now when Python accepts any input from the users, it accepts in the form of string. Given that string, even if it is given in numeric values, it can't subtract from numeric values. We have to first of all change or convert that string into numeric values, integer. See the result. Missing parentheses in call to print. So especially nowadays, the current Pythons are requiring to put them in bracket. Whatever you want to print. It accepts when the variables or whatever you want it to print in bracket. But earlier versions doesn't require bracket for printing. So we are inputting name of a person, and then it asks again print what year were you born. The problem here is the quotation mark is not closed. So we have to close that quotation mark. By following the error at every instruction, we can correct immediately rather than waiting until all instructions are executed. For print, we have to put it in bracket. Whenever you modify, you have to save. Then it asks me, what is your name? My name is Alex. What year were you born? 2018. Now there is a problem. It says, line 7, print string is integer years old, name then 2021 minus birth year, unsupported operand types for int and the string. So there is a confusion. That means we are trying to subtract from 2021 birth year, but actually when we accept birth year through input, it is already a string. So to subtract, first of all, we have to convert birth year into integer. That means we have to cast int, then birth year within bracket. Now if we run it, what is your name? Alex. What year were you born? 1986. Alex is 35 years old. So at this point, what you have to remember is when Python accepts input, the input is accepted in string format. If you want to apply arithmetic operators, first we have to cast the string into integer number as per the requirement. Then it will work. So it accepts integers, floats, it accepts string. Again, at this point, like we do in Java and C++, dividing integer by integer only returns integer. 5/2 is 2.5. But since we are dividing integer by integer, the solution is 2. To display 2.5, one or both of them should be in decimal number. We have to say 5 point or 2 point or both 5.0, 2.0. Then it will display in decimal number also 2.5. All algebraic operations are supported in Python. Addition, subtraction, multiplication, division, even a remainder. %AB will return the remainder. Exponentiation, which is tough in C++, unless and otherwise we import maths. Here directly, if you use A ** B, A, the power of B, will be calculated. 2 to the power of 3, 2 times multiple multiplication times 3 will give us 2 to the power of 3, which is 8. So exponentiation is also supported in Python. Comparison operators, all are there. Greater than, less than, is equal to, not equal to, all are possible. When we are adding, rather than saying, as we said earlier, x is equal to x plus 1, you can simply say x plus is equal to 1. Whatever you want to add, or whatever you want to subtract. but plus plus minus minus are not possible. Plus plus minus minus is possible in C++. Why? If you are adding always 1 1. But in Python, it doesn't allow, because it may be 2, it may be 3, whatever we add. So we have to explicitly tell how much you want to add every time. Assignment. If now we assigned for a given variable numeric, next time if you want to change the assignment to another data type, it's possible. Even on the same line, we can assign multiple variables with multiple values. Just every variable should be separated by comma. The major thing, string manipulation is possible in Python. There are many manipulations we need from string. Even in Python, there is no character. Starting from 1 character, it is a string. So whether you are using single quotation, double quotation, they are to say string. Single quotation for character, double quotation for a string doesn't work here. You can use whatever you want to use, but everything is a string. When it accepted, it is a string. If it is 1 character, it is a string again. So given string, we can easily concatenate 2 strings just by using plus sign. It's also possible to duplicate a string multiple times by saying multiply with 3. Like here we have it accepts name. I want to duplicate name multiple times. Is equal to 3 times name. Then if you want to concatenate it, name with name plus sign in behind. If I say print name, even when you are printing, you can write the title or the descriptor, write name. Then with comma, the variable. What is your name? Alex. Years born, 1989. So Alex is written how many times? 3 times. Alex, Alex, Alex. Because we said 3 times. If you want to concatenate Alex with Alex, add, in fact, in this case, if I say 2 times, that's enough. If you want to concatenate different variables, for instance, we want to concatenate name with Alex Ethiopia. So the name is concatenated with Ethiopia. Alex 1999. So Alex is concatenated with Ethiopia. So for concatenation, for concatenating strings, we use the plus sign. for duplicating a given string multiple times, multiply with the number of times we want to duplicate. Then also knowing the length of the string is possible using len, length. If I want to print the length of name, write length of name. Name is Alex, 1998. So the string length of name is 13. Why 13? Because we concatenated the given name with the string Ethiopia. Even it is easy to whatever words you are writing, if they are in a small letter, we can convert them into capital letter into small letter. Like if I say name upper rather than length, the given variable which contains some string dot upper is a function. Then it will convert it into upper, the string that we give in the form of variables. So the variable or the name of the string should come at the back of whatever function, upper, lower. Now if you print, if you want to loop it, name of I, name of J, again, the name is Alex. So the one I write Alex and the one which is also concatenated Ethiopia, all are now in capital letter. So for normalization purpose, we can use just capital to convert from small letter to capital letter, from capital letter to small letter. For small letter, we have to use lower. So string manipulation becomes very easy. So the other thing is we can also access parts of a string, because parts of the string are indexed already, starting from 0. 0 is the first character, the last character is n minus, the length of the string minus 1. String string 1, 2, 3, 4, 5, 6. So that means the index is 0 to 5. If you want to access character at index 1, S of 1 will give us T. If you want to access from 1 to 4, 1 to 4 means the first character is ignored, then T, R, I, and the last character is ignored. When I'm saying from 1 to 4, it means that 1 to 3. The first index is given, but the last one is not counted. So it goes on starting from a given point up to I minus 1. To print all up to this, you can say empty up to j. That means from the beginning up to j, excluding j. When we are saying up to 3, excluding 3, 0, 1, 2, those characters at 0, at 1, at 2 are printed, stri. We can also go starting from a given point up to the last. That means starting from I until the end of the string. Even you can define also per what character to print. It can go from 0 up to 5 in our case, string. But if we wanted to print per 2 characters, starting from the beginning, from 0, it prints the second one, then the third one is skipped, and the fourth one is printed. So as per our requirement, we can manipulate the substrings also. Especially this one is good when we are dealing with like stemming. Stemming at the end. Suffix is happening at the beginning, prefix is happening. After calculating what kind of prefix or suffix we are trying to ignore, then we can go up to that suffix, or we can go identifying the prefix accordingly. If you have a list of suffixes and a list of prefixes, we can easily compare. If statement, conditional statement, loops are also possible. How can we write if condition? We know if is the if condition. If there is another option, we can go for else if. Then if there is the last option, else. Both are supported, if, else if, else. If, then if you have else if, elif, then else. But remember, for the condition, we don't need bracket, but at the end of the if condition, colon is required. Colon will help us to, or it helps Python to automatically indent. And it will show you the position where to write under if condition. We don't need the braces. Just the indentation will guide Python what are the statements that should be executed under if condition. So colon is important. If I go to Python, if I say if x is greater than 3, no need of bracket, associate x greater than 5, then colon. When I press, it will automatically indent for you where to write. Print. Print the value is but we have to tell the initial for the time being. X is equal to, say, 4. Then it will exit without printing. But if I say 8, the value is X. Then it will print. But basically, when we are writing if condition, it should be under some loop to make it iteratively work as per the given statement. So basically, don't forget colon. We may forget indentation, but indentation is critical. If you put colon and then press, enter, then it will indent for you where to write the next statement that should be executed under if condition. So when you are writing if conditions, if you have only two options, if and else, we can go if this condition true, do this, otherwise else do this. If you have else if condition, to check maybe 1, 2, 3 instructions are required to check positive, negative, 0. Then we need else if. For else if, we are using not else space if. Here we are using ELIF. In addition to IF, we are adding as the back of it as a prefix EL. Elif means else if. Again, if else if is false, then finally we'll get else. But at every point, if condition, elif condition, else condition, there should be a column, based on which indentation is required. Whatever statement that are executed under if, under elif, under else. Like if a is equal to 0, print 0. Else if a less than 0, print negative. Else print positive. If I take this one to Python, what will happen? If I copy if a is equal to 0, print 0 to make sure that the indentation is correct. After colon, if you move print and enter return, then it will put it in its proper position. Then for else if, elif a is less than 0, then colon to make sure that the indentation now print negative. Then else, again after colon, if you check it, print then quotation mark. Now save. So before this, we have to accept. Print. In fact, even we don't need print. Just a is equal to input value of a. Value of a is 9. Why it displays an error? Because when it accepts whatever number we are giving it in the form of number. So whatever we accept, then we have to convert into int if it is integer. So when it accepts input, it accepts in the form of string. Now it will display the right result. If you run again and give it some other number like 0, it will say it is 0. So basically, after if condition, for the condition we don't need bracket, but at the end of the if condition, else if condition, or else condition, there is a need of colon. Then after colon, if you press, it will tell you at what indentation we have to write the sentence that should be executed under the if condition. So here, this kind of misplacement may result in an error. So if you have two conditions and if possible again, you can use or, you can use and. The other thing is we need also while loop frequently. In general, we need loop to execute something multiple times until all the inputs are analyzed. For that, creating loop is required. Like one is the while loop is accepted. While this condition is true, do this. Again, after a while, we have to write the condition to check whether it is true or not. If true, then it will execute iteratively again and again. Then finally, there should be a colon. Then it will indent for us to write whatever instruction executed under the while loop. So here x is equal to 1. One of the challenges with while loop is what? One of the challenges we have to tell explicitly the starting point, then the condition for the final termination point, and then also incremental point. So there are 3 points. This is the starting point, this is the end point, this is the increment. If one of them is missing, something wrong will happen. In comparison, the for loop, when we define it, since it is a must to specify both the starting point, the ending point, and the increment, mostly problems will not happen. But sometimes we need the while loop itself. Like if you are writing operating systems, which always run, unless and otherwise the user close the computing system. So in while loop, you have the starting point, ending point, and an increment. But what about for loop? For this, in range of this, do this. So it takes one value from the range. The range is from this to this, starting from 0 up to 9. There are 10 values. So the range is running from starting from 0 up to 9. Every time it takes one value and assign it to A. So with one statement, we can specify where to start, how to proceed, and where to finish. In the case of for loop, we can say for I in range of 1 to 7, do. For I in range of 1 to 7 means I is taking starting from 1 up to 6, because it goes up to minus n minus 1, since the index starts from 0. But after writing for I in range 1 to 7 colon will help us to indent. Then it will print all what we want to print. For statement is especially good when we are writing a compressed code plus a code that doesn't need to tell explicitly in different lines for starting, for ending, and for incrementing. Take this statement. L is equal to these numbers. It contains, a list contains 4 values. Then through len is length. We know the length of the list is 4. So starting from 0, it goes up to the third index, 0, 1, 2, 3. Then the range will tell us where to start, up to what point to go, incrementally by adding 1, 1 and assigning it to I. Then we can take 0, 1, 2 as an index, which indicate like you are writing an array, index-wise, the values that exist at a given index. But in Python, both are possible. One reaching to a given value through index or directly reaching to the value itself. So having a for loop, and internally within that for loop, we can write if conditions. If you want to differentiate, like we do earlier, for I in range of length n, we can say if it is positive to write positive, if it is negative to write negative accordingly. So sometimes within for loop, you may need conditions. So in such a case, we have to use the if, else if, and else conditions. And accordingly, while it is looping, alternatively, it may go to if condition, else if condition, or else condition. Then write if there is a print. We also need, in any looping, whether C++, Java, 3 major operations. Sometimes maybe we want the loop to break before completing, if we reach the point where we need it to reach, or we want it to continue, like if there is 0, or there is some thing that it may be needed to write, but if that point needs to be jumped and moved to the next instruction or the next value, we have to say continue. Then it will go to the next instruction. Or we can say pass also. Like mostly when the denominator is 0, what will happen?